speaking of the reviews, there's something in the video that we need to emphasize. You can charge this up until the voltage or potential difference across this is the same as the batteries. Okay, so let me say it again, despite the fact that the second time around when I say it, it's not going to make any more sense. I just like saying it because it sounds so obscene. I can charge this up until the voltage or the potential difference is the same as what's supplied by the battery. Okay, now that I said it twice, the third time around, we got to kind of explain the meaning of it. All right, so what is the meaning of that statement? These little statements. Okay, put it aside. Let's get back to the definition of voltage and voltage difference. There's a reason why I spent so much time talking about it. All right, so this is going to be a positive charge. This one is going to be negatively charged. And then what that means is there's going to be an electric field in this direction. And there's a separation distance amount. Okay, so let's use D because that's what we're using in this chapter. Strength of the electric field times the separation distance is going to give you the voltage difference. All right, so that is the voltage difference between these two plates. All right, notice that this is what the battery is supplying. What does the battery do? Battery is going to charge this one up positively. Battery is going to charge this one up positively and this one up negatively until the strength of the electric field within the separation distance is such that the voltage difference is equal to the voltage supplied by the battery. Guys, this is known as the conservation of energy. The amount of energy supplied by the battery is exactly the same amount of energy stored within the capacitor. That's what it means in the form of these charges. Got it? So the voltage difference between the capacitor cannot be any larger than the energy supplied by the battery. All right, so this voltage and that voltage, they will be the same. So the battery is going to charge up until the voltage supplied by the battery is the same as the voltage of the capacitor. All right, stronger the battery is, more charge you're going to be able to store in the capacitor. That's what it means. If I double the voltage, you will be able to double the amount of charge stored. If you make this 10 times larger, the amount of charge that you're going to be able to store is going to be 10 times larger, provided that the capacitor is able to hold that amount of charge. Okay, whatever that means. So let's play with the concepts. All right, so various capacitors. They kind of look like that. You got a parallel plate capacitor. I don't want to do any math right now. Just want to play with the concepts. All right. What I want you guys to do at this point is I'm going to give you 3 formulas to focus on. And those are the formulas that we will get to use in answering the following questions. All right. This first formula is the capacitance formula. No, general formula. Q equals CV. That's the first one. And this second formula is the capacitance formula. And what else can we use? In addition to these 2 formulas, we can probably use the strength of the electric field times the separation distance. It's going to give us the voltage. And inside the capacitor, the strength of the electric field is going to depend on the charge density. All right, so bunch of multiple choice questions. 1, 2, 3, 4 formulas that we will get to use. All right, so we got 4 formulas. Okay, so I'm going to reference these formulas by numbers. Okay, so I'm going to give you guys a few minutes to figure things out, and whenever you're ready, just jump in. All right, so whoever answers the question, I'm going to give you 5 participation points.
It'll be the same.
Okay, hold on.
D.
All right. All right, who wants to attempt this? Whenever you're ready.
Am I muted?
No, you're not muted. I'm just evidently ignoring you. I don't know why. Hold on, Ian. Okay, so what do we have? We got a parallel plate capacitors. They're identical in every respect, except that one has twice the plate area of the other one. Okay, so we got 2 separate parallel capacitors. One of them has a surface area which is going to be twice as bigger than the other one. If the smaller capacitance is a capacitance of C, the larger one has a capacitance of All right, so Ian, what do you like?
I like D.
You like D. Okay, so Ian likes D. Does anybody have a different preference?
Like A.
I like A as well.
Okay, so Nathan likes A. Who else? Lucas also likes A. All right, anybody else wants to chime in?
Oh yeah, I agree for A too.
Okay, so you agree with A as well. All right, let's check to see which one. And then if you're right, those of you guys who commented, I'll give you 5 points. And those of you guys who did not, if you get the right answer, give yourselves 2 points. All right, how does this go? It's got a surface area which is larger. If the surface area is larger, the capacitance is going to be larger, so it's going to be able to hold more charge, right? If the area is twice as large, capacitance is going to be twice as large, so the charge is going to be twice as large. Okay, so if that's the case, which one is the best answer? All right, A is the best answer. So those of you guys who responded, give yourselves 5 points. Ian, give yourself 2 points for at least speaking out. The rest of you guys who pick A, give yourselves 2 points. All right. Once again, whenever you're ready. All right, so what do you guys think? So you double the area, and then you cut the distance by half. So what happens to the new capacitance?
It would be D, I think.
Okay, so D, how many of you guys?
Yeah, D.
Okay, so D. All right, let's check to see. So what do we do? You double the area. Oh, damn. I don't want to commit to it. Double the area, and then you reduce the distance. If you double the area, capacitance is going to go up. If you reduce the distance, it's going to go up again. So you double the area, reduce the distance, this thing is going to go up by 4, which means that the charge has to go up by 4, right? All right, so the best answer is going to be D. So those of you guys who picked D or argued in favor of it, give yourselves 5 points. The rest of you guys who picked D, give yourselves 2 points. All right, so study this, take all the time you need. Whenever you're ready.
I'm gonna go with B.
Okay, one person pick A, one person pick B. Did you say B? As in boy?
Yes, B as in boy.
Okay, anybody else?
I think for me, I think I'm gonna choose B. Just
All right, we got 2 for B. All right, so let's analyze this. I think we may have to add on to the lecture. So this parallel plate capacitor is fully charged using a battery, and then the battery is removed. All right, and then, which means that the amount of charge on the plates will remain constant. So it says, and then what do? The plates are immediately pulled apart. So we will just pull the plates apart. So what happens to the potential difference between the plates is they're being separated. All right, a number of ways of doing it. I'll just go over all of them, okay? Before we actually discuss that, let's discuss this. Whenever you charge up a capacitor, and then if you were to remove the battery, charge on this one is gonna remain constant. Okay, so if it gets charged up, you remove the battery, the amount of charge in the capacitor will remain constant. Okay, that's the case we're dealing with. So this thing charged up, which means that the amount of charge here is gonna be constant. This is constant. So if this remains constant, all right, so when you actually increase the separation distance between the plates, the capacitance is going to go down. If the capacitance goes down, the voltage is going to go up. So that's what happens. All right, so that's one way of looking at it. All right, so whoever picked A, give yourself 5 points. The rest of you guys, if you picked A, give yourself 2 points for that one. All right, that's one way of looking at it. This is a mathematical approach. It's fine. All right, so the charge remains constant, so this is constant. Increase the separation distance, the capacitance goes down, the voltage is going to go up. Boom, boom, boom. That's fine. The sort of stuff that you will get on the conceptual portion of the test is, what would happen if I were to increase the separation distance by applying a force on this, external force? All right, so you're applying a force on it, you're causing a displacement, which means that you're doing work on it, which means that the energy is being transferred, right? So you're doing work against the conservative force field, so the amount of work that you do is going to go into the potential energy of the capacitor. Got it? So it goes into the potential energy of the capacitor. It's the same concept here. The amount of charge is constant. Increase the separation distance. Capacitance goes down. Capacitance goes down. The voltage goes up, which means that the amount of energy stored inside a capacitor is also going to go up. All right, we're still playing with the first 2 formulas, so let's make it a little bit more interesting at some point. All right, so moving forward. All right, once again, guys, whenever you're ready, just jump in.
it decreases. So that'd be B.
All right, so B is one answer so far. Does anybody want to agree, disagree? If you disagree, do you have anything else that you guys want to contribute?
Would it be C because if the voltage test remains constant and as they're being pulled apart, the capacitance is lower, so the charge has to be bigger?
Okay, so we got B and we got C. It's either going to increase or it's going to decrease. All right, so
By the argument for C.
okay, so we have 2 for C, one for B. All right, we got 3 contributions. So let's investigate. So what do we have? Number 1, this time is hooked down to a voltage supply, which means that the voltage is going to remain constant regardless of what you do, guys. The amount of energy supplied and the amount of energy stored inside the capacitor is going to remain constant. Okay, so the question is, what happens to the amount of charge on the plates? Okay, let's analyze. All right, so this time, this is constant. This is going to remain constant. So increase the separation distance, the capacitance goes down, the capacitance goes down, the amount of charge that it's going to be able to hold is going to go down. All right, that's it. So voltage remains constant, voltage remains constant. Increase the separation distance, the capacitance goes down. If the capacitance goes down, the amount of charge is going to go down. This is constant, this goes down, this goes up. Okay, I screwed it up. Increase the separation distance, the capacitance is going to go down. If the capacitance goes down, the amount of charge that it holds is going to go down. And so best answer is going to be B.
I just
Given
went the
voltage,
wrong way.
if you got the right reasoning, I think the explanation was kind of. All right, so increase the separation distance. The capacitance goes down for a given voltage, which means that with capacitance, it's the amount of charge that it's going to hold is going to go down. All right, those of you guys who got the right answer, give yourselves 5 points. Those of you guys who commented on it, give yourselves 5 points. And the rest of you guys, if you got the right answer, 2 points each. All right, moving forward. Okay, this one is weird. All right, now we have to expand our selection.
I think it decreases.
All right, so you think it's going to decrease. Anybody else? We can have 2 more comments.
I think it might remain the same.
You also like C?
A.
Oh, you like
constant.
A, remains constant. All right, that's fine. Does anybody else want to contribute? Okay, this one is kind of weird. All right, so it's kind of weird. It's kind of weird. Okay, so what do we have? So number 1, it's constant voltage, means that it's hooked onto a battery as they're being pulled apart. So what happens to the strength of the electric field during this process? Okay, there are 2 ways of looking at it. One of them is an easy way of doing it. Look, guys, if it's hooked onto a battery, voltage remains constant. This remains constant. So if you increase the separation distance, strength of the electric field is going to go down. All right, that's one way of doing it. This is, all right, so voltage is constant. This is constant. Increase the separation distance, the strength of the electric field goes down. That's number 1. Okay, we'll arrive at the same conclusion the long way now. All right, this is constant. Increase the separation distance, the capacitance goes down. The capacitance goes down, the charge goes down. When the charge goes down, the strength of the electric field is going to go down. This was a 3-step process. All right, the simplest one is this one. All right, the voltage is constant. Increase the separation distance, the electric field goes down. And the other one is an extension of what we've been discussing. Voltage is constant, increase the separation distance, the capacitance is going to go down, capacitance goes down, the charge goes down. If the charge goes down, the strength of the electric field is going to go down within the capacitor. All right, so it's boom, 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 all over the place. All right, so C is the best answer. So for C, give yourself 5 points. Those of you guys who picked C and did not comment,